Far below the reach of sunlight, beneath the restless surface of the oceans, lies a world where day and night no longer exist. Here, darkness is not an absence of light but a permanent condition, a defining force that shapes every form of life. Pressure crushes with the weight of mountains, temperatures hover near freezing, and food is so scarce that survival itself becomes an exercise in patience. In this hostile realm, where most creatures struggle merely to exist, the deep-sea anglerfish reigns as one of evolution's most unsettling masterpieces. It is a predator that does not chase, does not rush, and does not waste energy. Instead, it waits, and in waiting, it has learned how to turn darkness itself into a weapon. The deep-sea anglerfish belongs to the order Laphiformes, a lineage that diverged long ago from its shallow water relatives and adapted to the crushing depths of the ocean. Over millions of years, natural selection shaped a creature that looks almost unreal, as if it were designed specifically to haunt the human imagination. Its body is often bloated and asymmetrical, its mouth disproportionately large, lined with long, translucent teeth that curve inward like prison bars. These teeth are not meant to chew or tear. They exist to ensure that once prey enters the mouth, escape is impossible. In the deep sea, energy is precious. Every movement costs calories that may not be replaced for weeks or even months. The anglerfish's physical form reflects this brutal economy. Its muscles are soft, its bones lightly calcified, and its metabolism slow. It is not built for speed or endurance. It is built for efficiency. And nowhere is this efficiency more evident than in the anglerfish's most famous feature, the lure. Extending from the top of the anglerfish's head is a modified dorsal spine known as the elysium. At its tip is a fleshy, bulb-like structure called the esker. This lure glows with an eerie, cold light, produced not by the fish itself, but by bioluminescent bacteria living in a symbiotic relationship within the esker. In the absolute darkness of the deep sea, this faint glow becomes a beacon. Small fish and invertebrates, drawn by curiosity or confusion, drift closer, mistaking the light for food or a potential mate. The anglerfish does not pursue them. It simply waits, motionless, until the distance is close enough. Then, in a fraction of a second, its jaws open wide, creating a powerful vacuum that pulls the prey inside. This hunting strategy is perfectly suited to an environment where encounters are rare. The anglerfish does not rely on frequent meals. When it feeds opportunistically, consuming prey nearly as large as itself. Its stomach can stretch dramatically, allowing it to store energy for long periods. In a world where food may fall from above only as occasional drifting carcasses or scraps of organic matter, this ability is essential. The evolutionary history of the deep-sea anglerfish is a story of extreme specialization. As ancestral anglerfish moved into deeper waters, they faced challenges unlike any in shallow environments. Light disappeared, pressure increased, and temperatures dropped. Vision became less useful, while chemical and mechanical senses grew more important. The development of bioluminescence marked a turning point. In the absence of sunlight, producing light internally offered a powerful advantage. Over time, the anglerfish refined this ability, outsourcing the task to bacteria that could glow continuously with minimal energy cost. The relationship between the anglerfish and its bioluminescent bacteria is one of nature's most intimate partnerships. The fish provides the bacteria with nutrients and a protected environment, while the bacteria supply light. Without this light, the anglerfish would be just another ambush predator in a nearly empty world. With it, it becomes a living trap. But the anglerfish's strangeness does not end with its hunting strategy. Its reproductive behavior is among the most extreme examples of sexual dimorphism and parasitism in the animal kingdom. In many deep-sea anglerfish species, females are vastly larger than males, sometimes by a factor of 10 or more. The female is the iconic image, large, fearsome, and luminous. The male, by contrast, is tiny, fragile, and lacks a functional digestive system in adulthood. In the deep sea, finding a mate is perhaps an even greater challenge than finding food. The vastness of the environment means that encounters between individuals of the same species are exceedingly rare. To solve this problem, male anglerfish evolved a radical solution. When a male encounters a female, he bites onto her body and never lets go. Over time, his tissues fuse with hers. His circulatory system connects to the female's, and he becomes entirely dependent on her for nutrients. Eventually, he is reduced to little more than a pair of testes, permanently supplying sperm whenever the female is ready to spawn. This reproductive strategy, while shocking to human sensibilities, is a logical response to the deep sea's constraints. By permanently attaching to a female, the male ensures reproductive success in an environment where a second chance may never come. For the female, carrying one or more males guarantees that fertilization is always possible. In the deep sea, efficiency is not a preference. It is a requirement. The habitat of the deep-sea anglerfish typically ranges from depths of several hundred meters to well over 2,000 meters below the surface. At these depths, sunlight cannot penetrate, and the water is perpetually dark. Temperatures are low, often just above freezing, and pressure can exceed hundreds of times that at sea level. Few animals can survive under such conditions, and those that are often slow-growing, long-lived, and highly specialized. Anglerfish are generally solitary creatures. They do not form schools or social groups. Each individual occupies its own small territory, drifting or resting motionless in the water column or near the seafloor. Their coloration is usually dark, ranging from deep brown to black, helping them blend into the surrounding darkness. In this environment, camouflage is not about matching colors, but about avoiding contrast. Any unnecessary movement or reflection could reveal their presence to both prey and predators. Despite their fearsome appearance, deep-sea anglerfish are not dominant apex predators. They occupy a mid-level role in the deep-sea food web. Larger fish, sharks, and marine mammals may prey upon them, though such encounters are rare. More often, anglerfish feed on smaller fish, crustaceans, and cephalopods that wander too close to the glowing lure. In doing so, they help regulate populations within this fragile ecosystem. The deep sea itself plays a crucial role in Earth's overall ecological balance. It acts as a massive carbon sink, storing organic material that sinks from surface waters. Creatures like the anglerfish participate in this process by consuming sinking prey and redistributing energy within the depths. Though largely unseen by humans, their existence is intertwined with global systems that influence climate and ocean health. Human understanding of deep-sea anglerfish remains limited. Much of what is known comes from rare submersible observations and specimens accidentally caught in deep-sea fishing operations. The deep sea is one of the least explored environments on the planet, and each expedition reveals new species and behaviors. Anglerfish, elusive and fragile, are difficult to study in their natural habitat. Removed from the crushing pressure of the deep, their bodies often deform, making accurate observation challenging. Modern threats to deep-sea ecosystems are growing. Deep-sea trawling, mining, pollution, and climate change all pose risks to environments that recover extremely slowly from disturbance. Because deep-sea species like anglerfish grow slowly and reproduce infrequently, population declines can take centuries to reverse. Damage inflicted today may persist far beyond human lifetimes. The deep-sea anglerfish stands as a symbol of life's ability to adapt to even the most unforgiving conditions. It challenges our assumptions about beauty, intelligence, and survival. In a world without light, it learned to create its own. In a place where movement is costly, it learned to wait. In an environment where meeting another of its kind is unlikely, it rewrote the rules of reproduction entirely. To encounter the deep-sea anglerfish, whether through a submersible's camera or the lens of a documentary, is to glimpse a reality far removed from the sunlit oceans we know. It is a reminder that Earth's greatest mysteries are not always hidden in distant galaxies, but beneath our own waves. In the eternal darkness of the deep sea, the anglerfish endures, glowing softly, patiently, turning the absence of light into the very tool that keeps it alive.